When you start getting a little bit of traction on YouTube, all these brands reach out to you and want partnerships. Okay, we'll talk about that at the end of the video. From the recent poll that I conducted on my Telegram channel, I got to know that the section with which most of you are struggling is the quant section. Now, the reason that I love this section is because the answer is either 0 or 1. It's a binary choice. There aren't any ambiguous choices like in reasoning or in English. So that is what I'm going to focus on as I take you through the basics of the quant section, and I'm sure that even if you're a veteran, you're going to get a lot of value out of this video. Join my Telegram channel to stay connected with important PDFs, links and other information regarding bank exam preparation. And if you like this video, please click on the like button and share it with your friends so that everybody can get access to this information. And if you are new here, my mission is to empower you with the tools you need to get success in all kinds of competitive examinations. So if you want to join me in this journey, please click on the subscribe button, and also do not forget to click the bell icon so that you, my friend, do not miss any future update. Let us begin with this video. Maths is love. Maths is the most beautiful thing, and I have so many reasons for that. I could tell you about Bernard Riemann's equations, which actually predicted that there are more than 3 dimensions almost 160 years ago. Or I could tell you about Leonhard Euler and about the Euler's identity, which was voted as the most beautiful equation on the planet. But I will not bore you with those details. Some other day, maybe I will talk about my fascination of maths and about all of these things that I just told you. Don't be confused. This video is all about the quantitative aptitude and how you can start your quant preparation. Now, the beauty about quant in these competitive examinations is that they are not going to ask you very difficult things. They are going to ask you very simple things, only up to high school level maths. So you are not going to face any kind of calculus, differentiation, integration, etc., etc. So with those simple types of concepts, they are actually going to frame questions that can tantalize you and that can actually cause quite a lot of problems. So how can we approach quant in the most comprehensive manner so that we do not stumble on those questions? Now, that is the main focus of this video series. So I will be covering a lot of things in this video, but in the coming videos as well, I will be delving deep into the quant section, and I promise you that after you complete watching all of these videos, you will be in a much better position with regard to your quant preparation. Just remember, maths is love. Okay, so the first thing is our objective in quant. So this is very important. I want you to understand about the elegance of these questions. So all these questions, when you see a question, when you are solving these questions, your main concept, it should be calculation should be less and you should be solving more. So calculate less but solve more. How can you actually do that? So let's take a small analogy. So if you have to make a wooden table and you have hammer and nails, so you will be hitting the nails with the hammer all day and you are creating that table, right? But what if you could actually find a drill, an electric drill? Wouldn't that make your problem so much easier? The things that you were wasting hours to do, you can do in minutes. So this is the most important thing about quant preparation. Try and find out the elegance of the problems. Try to attack a problem with different kind of perspectives. So that is what I'm going to show you as we go through this session and also the future sessions on quant. So we are going to try and simplify things using algorithms. We are going to use some techniques that can allow us to calculate less and solve more problems. So that's the main goal. And ultimately, of course, speed is your ultimate goal. So in these examinations, the thing is that if you have speed on your side, then you can have the ultimate prize, because speed is very essential. It is the ultimate thing that you need to aspire to. However, remember that speed is not the primary goal. So what is the primary goal? Of course, accuracy. You have to be very accurate in the quant section first. Without accuracy, you cannot tackle this section. This is very, very important. Many people, when they go and start with their mocks or when they start their sectional preparations, they will always try to time themselves. They will always try to do things fast. But that is a wrong approach. When you are starting off with your preparations, try and focus on the solutions part, on the accuracy part first. So you should actually get to a position in which if you are given time, you can solve the whole paper very, very easily. So this is what is very important primarily. primarily if you have any SBI PO prelims paper, any IBPS PO or mains paper, when you see that paper, if you feel that okay, if I had a few hours, I can solve each and every problem. That should be your first goal. Then the next step, which is speed, can be attained, but you cannot have speed without accuracy. This is very, very important. In the competitive examinations, your accuracy has to be about 85 to 90%. Remember this. If you are not at least 85 to 90% accurate in your papers, you are not going to get selected, because the competition is quite fierce. You cannot make any mistakes. Each mistake will fetch you minus 0.25 or minus 1/4 marks. So very, very important. You need to first be accurate, and then you need to reach for speed. And okay, the steps after the accuracy is mastered. So if you have mastered the accuracy, how are you going to build that speed? And I have already discussed this in many of my preparation strategy videos, so you can check out my SBI PO video. There also I have talked a lot about this. You need to have some goals. So if you have reached a stage where you are very accurate, you know that you can finish off the paper if you have enough time, then you need to improve your speed using some techniques like mini goals. So for example, I will take 10 problems or 20 problems that I can solve within a stipulated amount of time. So for example, just try to solve 10 problems within 10 minutes. Once you have done that, then try for 20 problems within 15 minutes. And like this, you have to try and you have to improve your level. So that is when your steps come in after your accuracy has been mastered. You cannot do these things unless and until you have mastered your accuracy. And of course, elegant solutions. So whenever you are solving any quant problem, even if you got the right answer, try and see the solution, and then just look at the problem. See if you can try and solve it in a better way. The solution that you are getting to, there are many roads that lead to the same solution. This is the beauty about maths, that when you can see a problem, me and you can actually approach it in different ways, and we can each get to the answer. So your main objective is to get to the answer in as short a time as possible. Now let's get to the next section. So what are the tools that you need to master? Now this is also very important, that there are two kinds of differences. So there is prelims preparation and there is mains preparation. Now in my timetable video, I hope that you have already seen my timetable video. If not, go check it out. So in that video, I have told you how you can attempt the mock tests, and you have to have a good mix of the prelims mocks and the mains mocks. And then 1 month or around 6 weeks from the prelims exam, you only have to focus on your prelims mocks, and after that, when the prelims is done with, you will be focusing exclusively on the mains mocks. So there is a delicate balance. Now there is a slight difference between the prelims questions and mains questions. So in prelims, there are variety of questions and the difficulty level is a little bit lesser. In mains, the difficulty level goes up, and in mains you also have DIs. So I will be having separate sessions on the DIs in the future, but for now, just remember that in the main section, what happens, the problems, they actually complicate it using different steps. So the same problem can be given to you. For example, the same ratio problem can be given to you, but this time they have mixed it with a profit and loss problem, and they might have mixed it with a simple interest kind of problem. So 2-3 kinds of compound problems are asked, and sometimes you have to solve 3 problems, and then they will be asking you, for example, 1, 2, 3. These questions will be given to you, and then they will be asking you, is the value that you got in 1 greater than 2, or is it greater than 3, like this. So the compound problems like this, what they do, they actually increase the difficulty by making it more calculative or by putting it in a larger number of steps. So if you have the concepts with you, then you can tackle them without any problems. So always focus on concepts, and that is what we are going to see in this video as well. Now the basic formulas. So basic formulas I am not going to discuss. These things you should already be knowing. You should be knowing that the area of a circle, the perimeter of a circle, square, about all the various kinds of triangles you should be knowing. You should be knowing about the mensuration, all the formulas that you have. So the important formulas that you need to have, if you are a little bit confused about them, please let me know. I will give you a sheet or something like that, but I am not going deep into the formulas over here. So what I want to do is I want to help you to understand the concepts first, and of course about the tables, the squares and the cubes. So a lot of people will be recommending you to memorize all of these things, and to be frank with you, I really hate memorization, but still, if possible, memorize the tables up to 35, squares up to 30, and cubes values up to 25. So just try and memorize these things. But now coming to the interesting part, is there a way to avoid the memorization? Can you go away without memorizing all of those things? Well, there might be. So is there any way in which we can multiply better? So that is our objective, right? Like you, I also hate memorization of all of those things. So without memorization, how can we multiply in a way that can actually help us to get to the answer very, very fast? Is there a better way of multiplication? Yes, sure is. Now, let's start with something simple first. So let's say for the first case, I'll just show you 67 into 4. So this is just pretty simple. And if you are doing it normally by multiplication and then carrying forward again and again, it will take time. So in these situations, what you can do, just split the thing into smaller parts. So 60 plus 7 into 4. Now this becomes much more manageable. What you can do, it becomes 60 into 4, 240 plus 28. So this becomes 268. So in this way, it becomes much simpler. So you will find that many of the problems you can actually reduce like this into simpler terms that can be easily multiplied. So this is a standard way to do the multiplication. Now let us get into something bigger. So if there are two-digit numbers, so for example, let's take 53 into 42. If we do it over here using this same method that we just discussed right now, what would we do? We would do something like this, right? 50 plus 3 into 40 plus 2. Now how will we do this? Normal simplification, what we used to do. So 50 into 40, this is 2000 plus 40 into 3, so it's 120 plus 100 plus 6. So 2120, 2220, 226. So this is how the answer comes. Now these are actually quite boring. I know you are getting bored as well. So let's see something more interesting. So now let us get into how we can do the same thing using a faster trick. So the faster trick is 53 into 42. If you are doing it like this, what you have to do, first multiply these two things. 3 2s are 6. Write it over here. Then shift one side over here. When you are doing the next step, what is the next step? You will be multiplying, cross multiplying this one and this one. So 5 2s are 10, 4 3s are 12, and you add both of these things. So 5 2s are 10, 4 3s are 12. 10 plus 12, how much it is? It is 22. So just shift it one side. So it becomes 22. Nothing will be over here because this was our first term. The second term, you have to shift once. Now for the final term, what you have to do, 5 into 4, multiply these two. So 5 4s are 20. Again you shift once and do it like this. Now you just add it, 6 2 2 2. So 2 2 2 6. Easily you got the answer. Just imagine how we could easily get the answer to this to this multiplication of two-digit numbers. So let's try something different. So for example, let's try 75 into 48. Now in the same process, what you are going to do, first thing, 5 into 8s, so 5 8s are 40, right? 40. Then 7 8s are 56, 5 4s are 20. So 56 plus 20, how much it is? It is 66, 76. So just shift it one side over here, then write 76. Again, the next term we are going to shift again to the left side. So 7 4s are 28. So now what you have to do, just add them. So 0, 1, 8, 6, 3600. So easily you can get the answer. Any two-digit number multiplied by another two-digit number you can do using this small technique that I just showed you. So just review it yourself and see whether you can do it. I'll just show you another example. So for example, see 67 into 73. So how does this happen? 7 3s are 21. Okay, then shift another one. 7 7s are 49, 6 3s are 18. So 59 69 67. So 67 it becomes. Then 7 6 are 42. Now this becomes 984. So 4891. That's the answer. So this is how you can actually do two-digit into two-digit. Now in some rare situations, what will happen, you might have to do three-digit into three-digit. So if you are doing three-digit into three-digit, you can do similarly, just a little bit different. The formula remains almost the same. So let's say 425 into 334. You're doing this. Now what you have to do over here, the first step is the same, 5 4s are 20. So 5 4s are 20, just right. Second step is also same, 4 2s are 8 and 5 3s are 15. So 15 plus 8, it is 23. Again, we are shifting it to the left one side all the time. That's what we have to do. The third step is a little bit just you have to note. So 4 into 4 you have to do. Then you have to add 5 into 3, then you have to do 3 into 6. So 4 4s are 16, 5 3s are 15 and 3 2s are 6. So 6 plus 15 plus 16. So it becomes 37. So 37. Now the next step again, 4 3s are 12, 3 2s are 6. So 12 plus 6, it becomes 18. And finally 4 into 3, this is 12. So now just add this 0, 5, 9, 11, 3 4 1 4 1 9 5 0. This is your answer. So any 3 digit into 3 digit you can do, any 2 digit into 2 digit you can do. So in this way you can, my friend, multiply much better. So that's how you can do multiplication in a much better manner, and I hope that you have understood all of these things. If you have any doubts, feel free to let me know in the comments. I'll help you, I'll explain it again. And reading and skimming for data is the next thing. So I want you to have a very high amount of ease in reading. So try and read as much as possible, because your reading speed, it sometimes becomes a blockade to actually tackling these problems. And you also need to be able to skim for data. So whenever you are seeing a problem, I want you to see the numbers first. So if you see the numbers, you just pick up the numbers, you can write down on your rough sheet all the numbers, and then you can use those numbers in your calculations. So that will actually help you to do the problems in a much more faster manner. This is just a small trick that you can use. And the next thing is choosing problems. Now in the prelims phase, it is not so much important, but in mains, it is very important. It is critical that you choose the right problems. If you choose the wrong problems and you go down that solution track and you find that it's very difficult, then it can prove very difficult. So try and understand how the problems are structured, and this will come after practice. You can do some mocks and you will understand how you can actually choose the correct problems to do. So the next thing is ratios and fractions. Now this is a very critical part of your examination preparation, of your quant preparation. If you have a very high amount of command over ratios and fractions, everything becomes easy. So command over these make quant a breeze. Okay, that actually rhymes. So how can you actually have a lot of command over the fractions? Well, let's see. Fractions can be your friend. Fractions can give you one of the most powerful tools to simplify the tough problems. So I want you to actually remember a lot of fractions. So it's not actually difficult to remember. So you all know a few of them. So for example, 1 by 2. Remember that it is 0.5. Also remember the percentage associated with it. So 50%, because sometimes in some problems, I'll show you later on, either in this session or maybe the next one, where you can use these things that you have learned, and you can easily change between these three forms. If you change according to the problem actually becomes very easy for you. So 1 by 2, it's 0.5, 50%. So now what's 25%? So it's 1 by 4, right? It's 0.25 equals to 25%. Also remember 3 by 4, it is 0.75 and it is equal to 75%. Also the 1 by 5, it is 0.2 equal to 20%. And similarly 3 by 5, it comes to 0.6 equal to 60%. Then 4 by 5, this is 0.8 equal to 80%. And then like this, you can as much as possible, you can read all of these. So I actually earlier had made a table of these sorts, so I couldn't actually find it right now. If you want, let me know in the comments and I will just prepare a table of these things. So also remember, you have seen till 1 by 5. So 1 by 6, it is 0.167. It is actually 0.1666 recurring. So it's almost approximately 16.67%, say 16.67%. Then you also have 1 by 7, which comes to your 0.1428, approximately equal to 14.3%. 3%. You also have 1 by 8, which is 0.125. And remember that many of these are actually just some changes. So 1 by 4, if you divide it by 2, you get 1 by 8. So 1 by 3, if you get it divided by 1 by 6, so I have not written 1 by 3, it's 0.33. It's, if you divide it, you get it 0.167. Now 1 by 9, if you do this, it actually comes to your 0.11, which is about 11.11%. Now why am I telling you to remember all of these things? Because sometimes in some problems you might have fractions which are not easily separable, and if they are actually separable, they are separating into some minor fractions that contain these. So for example, when you are separating integers from these fractions, so I'll show you one example. So for example, 11 by 3. 11 by 3, what you can do? You can do it as 9 by 3 plus 2 by 3. Now 11 by 3, calculating this is much harder, but if you do 9 by 3, it is 3 plus 2 by 3, you already know, 0.67. So 0.67, you do it 3.67%. So like this, this is how you actually simplify the fractions. So 28 by 9, say, if you are given something like this, you can easily put it as 27 by 9 plus 1 by 9. So it becomes 3 plus 1 by 9. You already know 1 by 9 is 0.11. So you can put it as 3.11. So if you can actually do these things, some problems will become much simpler to you. So I will advise that all of these important fractions, just remember them. Remember the fraction, the decimal, and the percentage. These three things are very important. So I hope that gave you some ideas about how you can actually have a lot of command over the ratios and the fractions, and how you can actually use it. In the future sessions, we will actually tackle some problems and we will implement those, and you'll see how it becomes much easier. Now let's take a look into where ratios and fractions are used. So simplification and approximation, these things will almost always come in the prelims, and sometimes they may come in mains, though it's very rare, but prelims you'll always see them. So simplification, approximation, and quadratic equations, these things, questions from them will always be coming. So we'll discuss quadratic equations a little later. Just remember that for ratios and fractions, it's very important. Partnership problems and some simple interest and compound interest problems, they also have ratios and fractions used. Then you have the mixtures and allegations. These problems I will be showing you in future sessions how you can simplify them, and you do not need to remember any kind of formulas. Just using concepts, using ratios and fractions, you can simplify these problems. Then you also have the permutation, combination, probability. They also use the fractions a lot. Ages problems and time and work, they also sometimes use these kinds of concepts, and you can simplify the problems if you use them. And speed and distance are also there. And of course, boats and streams, one of the most favorite topics of the competitive exams. So because they are so important, let's take a look at how you can use the fractions and make these things much simpler. So the first thing I want you to do is take a look at this problem. So I hope you have paused and read it. So what do we have over here? Here, the ratio of the speed of boat in still water to the speed of the current is given to us. Okay, so the boat is to current we have given to us. So it's 10:1. Now, usually in these problems, we would use it as 10x x, but because the problem, it is structured in such a way that we can do it only with ratios. We do not really need to use any x or y or any other kind of variables. So if we have been given 10:1, that is actually enough for us to actually solve this problem. Now, we have been given that the ratio of the time taken by the boat to cover d kilometer downstream to the time taken by the boat to cover d minus 45 kilometer upstream is 3/2. So 3/2, that's the ratio that has been given to us. Now here we have the time, on top we have the time that is taken by downstream, and the bottom we have the time in upstream. Now what's the formula for time? We know that speed is equal to distance by time. So time is distance divided by speed. So we have d kilometer. So the equation that we have to form, d divided by your speed downstream. So downstream, both boat speed and the current speed will be added. So boat plus current speed will be there. And the next one that we have is d minus 45. And here we have the boat speed minus the current speed because it is downstream, right? So this is the exact equation that we have to form. Now, as I told you, we do not really need to use x or y over here. We can directly calculate using 10 and 1. So what we can do, we can just reframe this as equals to D by B plus C. So it is 10 plus 1, it is 11. So it becomes 11, and this D minus 45, B minus C, this becomes 10 minus 1, so it becomes 9, equal to 3 by 2. So if we cross multiply over here, the final equation that we are getting, that equation is D by D minus 45, and over here we have 3 into 11, so that is 33, and 9 into 2, that is 18. Now we have this final equation over here. What should we do now? We should just calculate and solve for D, right? Now this is where the elegant approach that I am talking about comes into play. We can take some time to solve this manually, but we can also see that, the numerator over here is D, and the denominator, it is actually lesser by 45, right? And so if we can somehow make this side the same, so try to understand what I'm telling you to do, which is that the numerator here, it is actually 45 greater than the denominator over here. So if you can somehow make the numerator over here 45 greater than what is over here below, then our problem will be solved, right? So how can we actually do this? Now try to understand that what's the difference between these two entities. So the difference over here, 33 minus 18, what is the difference? It comes to 15, right? So on the right hand side, the difference is 15. So if we can triplicate this distance, if we can multiply it by 3, what do we get? We get 45, right? So if we multiply both the numerator and the denominator by 3, then we are increasing the distance between these two things by how much? 45. So that is the goal. If we can increase that, so if we just multiply 33 into 3 and 18 into 3, we actually increase the distance between the numerator and the denominator, so that this distance equals to 45, and this is our final answer. So 3, the 3 that you get over here, that is the answer of your numerator. So D becomes 33 into 3, 99. So the value of D that has been asked in the question, the answer is 99. And we did not even need to solve this problem. We could just see the differences between the distances of these two, numerator and denominator, and we could easily get to the answer. So this is the elegant approach that you have to pick up. So I hope that you enjoyed understanding how you can actually use fractions and not calculate so much, and conceptually find the answers to these questions, and just try and keep thinking about these elegant solutions. When you find these elegant solutions, it's very, very interesting, and over time you can master them much better. Now coming to quadratic equations. So in the quadratic equations, there is a basic form of these equations. So what is the basic form? It is ax square plus bx plus c equal to 0. So that is the basic form, and of course we also have y equal to ax square plus bx plus c for the graph. So always remember the parabolic graph that actually it forms, so that you have a visual representation of how this actually works. You also have to remember the Pythagoras formula. So what's the Pythagoras formula for solution of the roots of a quadratic equation? So for the quadratic equation, we know that there are two roots, and you can find it using minus b plus minus root over b square minus 4ac divided by 2a. So this is the formula that you can use to find out the two roots. So that plus minus, you see, one root you find using plus, another root you find using minus. Now this thing inside b square minus 4ac, this thing, it is called the discriminant. Now depending on the discriminant, there can be various solutions. So if the b square minus 4ac, it becomes 0, then what happens? Then the roots are real and equal, because this part is totally becomes 0, so it becomes minus b by 2a, and both of the roots that we have, it becomes real and equal. Now what happens if it becomes greater than 0, this discriminant? If it becomes greater than 0, then the roots are unequal and real. This is also a possibility, and this is these two things are the only things that will be asked to you in the bank examinations. And you also have a possibility where this can be lesser than 0. So then what happens? We get into the territory of imaginary numbers, which are denoted by I, and this is actually root over of minus 1. I equals to root over of minus 1. So these imaginary roots, when it is lesser than 0, the discriminant, the roots are unequal and imaginary. Now the imaginary roots, they are not going to be asked to you in the bank exams, so do not worry about them. Only worry about these two scenarios, the real roots. Now is there a better way? Now I know that you all might be knowing how to solve the quadratic equations, but I promise you there is something that you might not know. So to solve quadratic equations, what do? We always need to have the equation in this form, right? Ax square plus bx plus c. So when we have the equation in this way, we can actually find the two roots of the equation. So the roots, it will actually be x minus r into x minus s. So if r and s, these are the two roots of the quadratic equation, then what's the practice that we follow? We actually find out that the sum of these roots, it has to be minus b, and the product of these roots, it has to be c, right? So this is the formula that all of us have been using since time immemorial. So this r plus s, this should be summing to minus b, and the product r into s, it has to sum to c. So this is what we have been taught earlier. Now if we actually need to find this product, so for example, let's take a real world example. So let's say that we have x square minus 8x plus 12 equal to 0. So if we have this kind of a quadratic equation, then what we can do, we need to find two numbers, the product of which will be 12, and the summation of those two numbers has to be minus 8. So this is our traditional method of solving the quadratic equations. But is there any new way in which we can do it? Yes, there is a new way. So let's first see the old way. So the old way, the roots that you have, both of those roots, they are given by this formula, right? Minus b plus minus root over b square minus 4ac by 2a. So this is the b that we have over here, the a we have over here, and the c over here which we have. So this is the formula that we have been using for a long time. Now very recently in 2019, Mr. Po Shen Lo of the Carnegie Mellon University has given us a very elegant solution and a very elegant way to tackle this problem. Now usually what we will be doing, we will be finding out two numbers arbitrarily which will be multiplying to get to 12, right? But this is actually a trial and error kind of a way. But in maths, there should be an elegant way to actually attack this problem. We do not need to do trial and error all the time. So how we can do this? So the key thing that you need to understand is that the two roots, the r and s that we are trying to find out, these numbers, they must be the same distance from their average. So that is how we have actually started with this process. So if we think in that manner, then we can find out two numbers like this. So we can say 4 plus u and 4 minus u. Can we say that the summation of these two will have to be minus 8, right? Of course, you have to add the negative numbers over here. That's not required. We are just taking only the roots. So 4 plus u and 4 minus u. If we take it like this, then we multiply them. Then we should get what? C. And c, what is c over here? It is the nothing but 12. So we can say that 4 plus u into 4 minus u, it is equal to 12. Now because these will cancel out, so a very elegant kind of a quadratic, a simpler kind of a quadratic equation comes, which is 16 minus u square equal to 12. Now u here, it will be square root of 4, which is 2. So it will be plus minus 2. So now what we can do, we can simply do 4 plus u and 4 minus u. So the answer becomes 4 plus 2 and 4 minus 2. So it comes to 6 and 2. So what are we doing in this kind of a process? To actually get to our answer, what we are doing is we are finding out two numbers which are minus b by 2 plus minus u. These are the two roots that we are actually tackling. So if we use this formula, then we can tackle any kind of quadratic equation, no matter what complicated quadratic equation is given to us. So let's take something a bit more complicated. So let's see x square plus 7x plus 12 equal to 0. Now this is a little bit more complicated, and it's 7 over here, so it's not divisible by 2. So what will be this over here that we have taken? It will be nothing but 7 by 2. So 7 by 2, this is our b by 2, so you have to put minus over here, plus minus u. So this is how we are going to approach it. Now since we are actually squaring this, so this thing we actually can write out as 49 by 4 minus u square equal to 12. Can we write this? Because see, we are taking it from here like this, we have written it over here. So similarly 49 by 4 minus u square equal to 12. Now let us just simplify this. So u square, this becomes 49 minus 48 by 4 equal to 1 by 4. Therefore, u becomes 1 by 2. So u becomes plus 1 by 2 and minus 1 by 2. So the answer for this, what it will be? The two roots are minus 7 by 2 plus 1 by 2 and minus 7 by 2 minus 1 by 2. So the answer, it actually becomes minus 3 and minus 4. So these are the two roots of this equation, and easily see how we are actually finding this. This is quite easy. We are not doing any kind of trial and error. We are just simply putting it into a formula and we are just getting the answer. So this is our main logic, that we have to put it into a formula. So let's take something even more complicated, and this was actually asked, I think, in the last SBI paper. So in 2019, 7y square minus 17y plus 6 equal to 0. Now remember that we cannot work with this. We have to have in this form, right? We have to have in the ax square plus bx plus c form. So if we need to do it in ax square plus bx plus c form, what we have to do? We have to actually divide it by 7. So we make it y square minus 17 by 7y plus 6 by 7 equal to 0. Okay, so now we can actually work with this. So what are our two roots going to be? Our two roots, they are going to be, now this minus b, so it becomes plus 17 by 7 into 2 plus minus u. So these are our two roots that we have to find the answer to. Similarly, just how we have done over here, this kind of an equation we are going to use. So squaring both of these things, 17 by 7 into 2, square of this minus u square, it will be what? It will be c. So what is c over here? C is 6 by 7, right? So we have to put it as 6 by 7. Now just simplifying this, it will be 289 minus 7 into 4 into 6 by 49 into 4. So this is your u square. So u square, it actually becomes 289 minus 168 by 49 into 4. So this becomes 121 by 49 into 4. Now this is u square, right? So we have to do a square root over here to find out u. So this becomes 11 by 7 into 2. So now let's write it over here. Our u, it becomes 11 by 14. Now we have to just use this formula and we have to find out the final answer, which is 17 by 14 plus u once, and this is the first root. Second root is 17 by 14 minus 11 by 14. This is the second root. So the first root, it becomes 28 by 14. So it comes to 2. And this one, 17 minus 11, it's 6 by 14. So it's 6 by 14. So this means 3 by 7. So 3 by 7. So see, even such a complicated equation like this, we could reduce very easily. We could put in this kind of an algorithm and we could get the answer very, very easily. So you have to try and put it into this algorithm, and you can solve any quadratic equation given to you in a very elegant manner. So I hope that you understood very well how you can solve the quadratic equations in a much more elegant manner, and you do not need to go for the trial and error method. In the complex problems, the trial and error method can sometimes create a lot of problems, but in the method that I showed you, you will always get the answer. It's just an algorithm that you have to follow. Now, how do you practice these things? Just remember that if there is any section in which you're weak, try and find out questions on that, and each and every day, whichever day, like I told you in the timetable itself how you will be allocating the days. So in the quant days, try and allocate the sums as much you can find of those things in which you are lacking. So on Telegram, on various other groups, you will be finding a lot of questions like that, and I'm sure that you do not really need to refer to any kind of paid materials. You can get it all easily for free. Keep practicing them in the manner that I have shown you, how you can structure your time and practice, and I am sure that in no time you will be a master of quant. That is all for this video. I hope that you learned something from this video and that it was beneficial to you. If you liked it, please leave a like, and please do not forget to share. And if you want to see more videos like these, please subscribe to my channel and click on the bell icon so that you, my friend, do not miss any future update. I'll see you in the next one. Bye bye. So a final note about sponsorships and what I was talking about at the beginning of the video. So basically I have been approached by a lot of companies and they want to tie up with me. It's all because of the love that you have for me and you are watching my content, commenting and leaving such great feedback for me. That's why maybe brands notice that. So most of them I have said no to, some of them I'm looking at, but the most important thing is that whatever I promote on my channel should be beneficial to you and should add value to your life. If I find something like that, I'll go forward with that. So this message is not actually for you, but anybody who is actually contacting me for partnerships or promotions. So this is the message that I wanted to give. That's all. We'll see you in the next one. Bye bye.